Hey guys, thanks for coming back. We're going to keep rolling with our hydraulic system fundamentals lecture. The last place we left off, we were talking about some pressure. I just want to add a couple things to that just real briefly. One of the things that particularly technicians will do, I've seen this in the field, is the first thing when a system that's hydraulically operated starts to malfunction, quits working altogether, or is struggling to make the moves and things like that. The first thing people want to do is they want to jack up the pressure of the hydraulic pump, or they want to jack up the spring pressure on the pressure relief valve. They think, okay, some pressure is good, more pressure's got to be even better. No, that's not the case. Usually if something is working just fine and over time it starts to go downhill, you got something going on, something is wrong, something is starting to fail, and the answer is not more pressure, okay? Most of the time it is a mechanical component that is either coming apart or failing. You could have a bearing going down that's requiring more force from the hydraulic system to complete a move. It could be, one of the hydraulic components themselves. It could be anything within that system that is involved with the hydraulic system. But the thing not to do is to go there and start jacking up pressures on your pump, or to set a higher relief setting for our pressure relief valve. Okay, all that's going to do is it's going to make something our weak link. Okay, it's going to move our weak link to somewhere else, and you'll tear up things. Not only if you have a part going down or a component going down, like a bearing, like I said, or something like that, or something is jammed or in the way or interfering. Not only is that going to be tore up, you're going to tear other things up in the process. So avoid going to our pressure settings first. Okay, look at the system and see what else is going on, what's wrong. Because I mean, I've seen that happen. Some of the technicians that have worked for me in the past crank up the pressure on a hydraulic system, and they wind up bending the rods on the cylinders and damaging things, creating a lot of heat, and they just tore up more stuff in addition to what was originally wrong. So my point in all this is use your flow gauges, use your pressure gauges too. Try to determine what's the health of your system, how's it operating, and if something if it's not operating the same way it was, a week or two previously, something's wearing down, something's going down. Otherwise, it would keep working the same way. So use that just very basic common sense. And again, like I said, a lot of guys will say, well, some pressure's good, more is better. Try to avoid that mentality as you go to try to troubleshoot. But we're going to keep moving on. I just want to tag that a little bit with our pressures from our last lecture. We need to talk a little bit more about some of our components and some of our, we got more formulas, I know. But what we need to do now is we want to understand how much fluid some of our components take. And that's very important when it comes to when they're designing the system, how much fluid you need to have on hand, and how much that system should have in it. So one of the things we want to talk about today is volume, okay? And that is really, for determining volume, is just one more number, okay? We already know how to figure out area, and we're going to use our new formula of diameter squared times 0.7854, okay? So got that down already, and we just got to add that, and that will give us the capacity, how much a cylinder or a reservoir, or even our line of hoses. You could have several hundred feet of hoses or piping conductors, and they all hold oil, and you got to make sure that there's oil there. You can't just fill up the reservoir and just think that's going to be enough. You've got to have enough to fill up the lines, because the lines have to be full for the system to work. Pretty basic. So we're going to figure out capacity real quick. It's not that hard. Again, I'm going to use an example. We've got a 4-inch diameter cylinder, and it's got a 24-inch stroke. We already know to square 4, that's the diameter. We square that, multiply it by 0.7854, and that gives us a cylinder area of 12.6 roughly square inches, okay? Now we got a 24-inch stroke. Well, it's real easy. All we got to do is multiply that area times the 24, and that's our volume. That's it, right there. Wind up with 302 cubic inches of volume inside of a cylinder, a 3-inch cylinder with a 24-inch stroke. So we have 302 cubic inches. but that really doesn't help us that much just yet. What we've got to do, we need to know the capacity, how many gallons of hydraulic fluid this particular cylinder will hold or consume. Okay, and it's real easy to take that, and we figured out our volume in the previous slide, okay, 302 cubic inches, that's our volume. All we have to do now is divide that by 231, and remember 231 is the cubic inch displacement of 1 gallon of fluid. So we're basically going to take our volume divided by our gallons, or 231, and that will give us our gallons of capacity. So we had 12.56, we divided the area, the volume there, by 231, excuse me. We had the 203 cubic inches, we divided by 231, and that's going to give us, this cylinder will take 1.3 gallons of oil. So you can imagine if you've got, say, 15 cylinders on a system, they're all relatively the same size or various sizes, you know, that's going to eat up quite a bit of your the fluid that's in our reservoir. 15 gallons is you know, a significant amount on some systems. Now, I've worked with systems that have had 2,000 gallon systems. Just the ram itself, just the cylinder itself, the diameter was roughly 4.5 feet. Diameter at 4.5 feet, not inches, but feet. And it was about 230 inches. It held 800 gallons of hydraulic fluid just in the cylinder itself. So the reservoir, once it evacuated and was raising that ram a full stroke, a lot of displacement going out of that hydraulic unit. So that's why we have to understand the volume of our cylinders and the volume of all that. If we just ignored it, we'd wind up running a system dry. So that's for cylinders with our area, you know, the diameter squared times 0.7854. But what if our area is not round like a cylinder, okay? What if instead it was rectangular or square, like maybe a hydraulic power unit, okay? I think the book gives us this example here with a length of 72 inches, a width of 36, and a height of 30, okay? Well, we're going to figure out the area of this because that comes into play with hydraulic power unit reservoirs, okay? So to get our area, we have to multiply the length times the width, and that's 72 times 36. That gives us 2,592 square inches, but we want volume, so we've got to have that third. Remember the stroke? We had the area, we had to have the stroke to find out the volume. Well, we've got the area, which is the length times the width. Now we got to get the volume, which will include height. So we multiply to get our area, the length times the width, and that gives us 2,592 square inches. We multiply that by the height, which is 30, and we wind up with 77,760 cubic inches displacement in this hydraulic power unit reservoir. So that's how we figure that out. Okay, but again, like with our cylinder, that's just enough to know the cubic inches of that cylinder, okay? Volume, we need to know the capacity, how many gallons of oil that will take. So again, we're going to use that magic 231 number. So to get the number of gallons in the reservoir, we take our volume, which was 77,760 cubic inches. We're going to divide that by 231, and this tank can hold 336.6 gallons of fluid. Some critical information to know, and that's if you fill it to the top. Now, you don't ever fill a reservoir completely to the top. There's a certain value, like if you want to make it, say you want to fill it 75% full, then you multiply that point by 0.75, and that gives you, you know, how much oil you need to have in the reservoir. But that is how we find out volume for a cylinder and its capacity, and we also figured out how to figure out its volume and capacity for a hydraulic power unit. So why is that important? Again, as I stated earlier, you've got to have enough oil to run through the system, and if you don't have enough in your reservoir, it'll allow it to run it dry, run components dry, burn up pumps and things like that. So it's imperative that you know how much it takes and make sure you have the ample and fluid in there too. You also don't want to overfill, because if you fill all your lines up and your cylinders out there are full of oil and you cut to the top, when they start retracting and start moving and bringing oil back in the reservoir, it's going to run over. So again, this is just a way, you know, we've kind of figured out how much oil we have. And I think one more slide we got here is the last thing here is now we're starting to get into our symbols. You should, I'm not going to tell you what these are. You might want to stop the video and see if you can identify them, just because you're going to need to be able to know how to identify them for the quiz and also for print reading, which is going to be a part of this too. So we got our motor, which is the M sort of gives you, that's our prime mover. That part right there, that part there, that part there, that part there, this part, which I will go into a little bit later. That thing there, these things, they're all components you should know. So we have started with you, a lot of you knowing nothing about fluid power, and we have moved along. We are getting some conductors and all of our components. You know, we're starting to learn the symbols. You're starting to be able to read schematics now. So we'll take this and run with it. So this is another really short one. I think we got one more and we'll be done for this particular lesson. But again, I just want to explain a little bit about volume and capacity, because those are critical when you're talking about an entire fluid power system. Okay? So again, we have talked about fluid power, we talked about pressures, we have talked about flows, we've talked about components, we've talked about all kinds of symbols on our schematics. So we're covering a lot of material. If you need any help with anything, just let me know, okay? Other than that, shut this one down and make sure you come back, because I'm telling you, we're just going to keep having more and more fun with this stuff, all right? I hope you are enjoying it. I kind of am. So we'll talk to you later. Thanks a lot for watching.